so let's start with an example that looks like this. We've got a function and it is f of x equals 2x squared minus x plus 5. Okay, so that basically is a parabola, it's a graph. And we want to know what are the values of y as the x values tend towards 3. Okay, so what is the limit of the function as x moves towards 3. All right, so just as I did in the previous example, imagine that yellow line moving along the graph as it gets closer to 3 from the left, and it's moving along the line as it moves closer from the right. And what is the y value that it's moving towards from both directions, okay? Now, you don't have to have a graph in order to do this. We can actually just work it out, all right? And the way we do that is we say equals, and we substitute the value of 3 into the x's, all right? Now, in this particular example, by substituting 3 into my x's, am I getting something that's undefined? Okay, well, the answer to that is no, I'm not. It's going to work out perfectly fine. We're going to land up with 2 times by 9 minus 3 plus 5. So we've got 18 minus 3 plus 5. That's working out to give us 20. So as the x values are tending towards 3 on the x-axis, the y values are going to be tending towards 20 on the y-axis. And the limit at the value of 20, the value of the function at the point where x equals 3 exists at the point 20 because there is no undefined value over there. Again, unlike the first example we did, where we did get that undefined value. Here the limit exists, it exists, and it's actually valid at the point where x equals 3. Okay. All right, so what do? We just substitute values into the x's. As long as we're not getting something undefined, we can just substitute in and we get the limits that we are looking for. We're going to do some more examples, so make sure you work with me.